Hello, today we are going to solve the problem of the day from LeetCode. This time the problem was a bit hard, and it basically gives us a list of words, and each word has some prefixes. They are asking us to basically per each word give the sum of the repetitions of each prefix and the repetitions across all of the vector. For that reason, for instance, in the first word, how many words have the prefix a, that is the first prefix? In this case 2, because AB and ABC. Then how many words have the prefix AB? In this case only 2. And then how many have the prefix ABC? In this case only this one. That gives us 2 plus 2 plus 1, that is 5. Then the implementation that I have come up is basically grouping inside list or vectors, let's say, and each vector each vector will have the characters, let's say, that have a common prefix already done, let's say. For instance, in the first case, I'm going to explain it by an example. Let's say that when we start with the problem, all of the words have the same prefix that is equal empty, basically, because let's assume that in all of the words that we have this empty string as a common prefix. Then we can group them and put in the following way. Let's say for the first one, we're going to add let's say 1 pair per each word. And inside this pair, the first thing that we are going to store is the index of the word inside the original vector. In this case, it will be 0, then 1, then 2, then 3. And then we are also going to store the position of the let's say the current position that we are traversing, or the current chart that we are checking to verify this. This will be 0, 0, and 0. Then the next time we are going to start let's say that, let's call it B, and we append B into a kiwi. Then the next time we are going to retrieve one element of our kiwi, or the front element of our kiwi, and we will have this. But now we are going to start to classify by the first let's say position in every string, and this will give us basically 2 classifications for which we are going to build some vectors. In this case, for the letter A, which of them have the letter A as common? We see that only the first 2 ones, right? That means that the vector for this letter will be 0 and then 1, because we need to continue with this next position, and 1.1 because we need to continue with the next position. Remember that each element of B is let's say word index and then character position inside word. This is the format. And then for B, we will have that B is 2, 1 and 3, 1. Then we will pass to evaluate. Now for for prefixes of length 1. Let's say this is prefix of length 0, prefix of length 1, and then we pass to prefix of length 2. With prefix of length 2 we have AB, and then now we are only going to have like 0, 2, and then 1, 2, because the first two strings are still valid. Then the other different prefix is BC, but this is only present in 2, let's say, because only the third element has this prefix. Then we can continue for prefix of length 3, and then this will be ABC, and then we will only have 0, 3. We use the word index to know basically the grouping, which indexes take part of the current group, and we will need to update them, because then for this index we need to add like the length of B, because we know that all of these elements are let's say then this represents in which words we have this prefix, and for each of the prefixes in each word we need to sum like the total. For that reason we sum it like for A, we sum it like the number of times that we had that prefix. This B is basically a representation of that, and we need to sum like the amount of times that this prefix is present. That means, that for instance we can initialize our answer, let's say, as 0, 0, 0, but then for instance here we are going to update answer 0 plus length B, and also answer the 1 plus length B, and we are going to do the same for this, the same for this, with its corresponding vector B. Okay, I hope that the explanation was more or less clear. I know that this is a hard problem, but if you have any question, let me know in the section below. Okay, then we're going to start with the implementation. For the implementation, we will going to need the length. Let's say length words. We're going to use also the length of the alphabet. That is 26. Then we're going to initialize the answer. Then we are going to create an array, because each time, do you remember that I mentioned that we are going to start adding these vectors into kiwis in a way that we can process each of them and delete after it's processed, because after it's processed it doesn't matter, it can be deleted. And in order to basically at each time that we process an element from the kiwi, have some space available to insert the new state that will be stored in the kiwi, we're going to use an array for that. And this array will be a vector of integers that will use the length of alphabet. Also, let's call it last new state. Okay, then we are going to create an struct for storing each of these pairs, and this struct will be call it, let's say, word state, and it will have an index that will represent the index inside the words vector, and also the position that will represent the position in the chart. Now we are going to create a queue that will store vector of word state, and let's call it as queue then we need to initialize like initial state and also we need to give this initial state a length of the amount of words that we have. Also then we need to initialize the initial state initial state push back. This is basically the initial state that I mentioned, that is basically all of the strings or words that belongs to the words vector, and yeah, for that reason it's representing like E and then 0. Then we're going to insert this initial state into the queue. We are using move in order to be more to have more efficiency during these operations, because move will not copy the vector. Move will like move the memory space to allocate it in the queue. Then we have while the queue is not empty, we need to get an state to start to word. And also we're going to use move for this step, and then we can start to work with this state to generate a new step. But also before starting to work with the new or populate the new state, we need to ensure that it is clear, because otherwise we can have values from previous processings that will affect our answer. Yeah, then sorry, here is LM. Then we can start with the states. State and we can like decompose the each state. I'm going to use IDX and post to abbreviate basically. And this is each states represents like these things. After that we have this, we need to check the position is less than the length of the current, let's say, word. And how we know the word? Basically because we have their index. Say words index and size. I think that this is not required, it automatically parses. And then if this is the case, then we can like start to populate our new state. And our new state is grouped by each possible character. For that reason, it is using like the length of the alphabet to its initialization. Yeah, then we have new state, and then we are going to convert the chart to integer. And then we are going to add the index, because this means that, for instance, let's say that we are in the letter B, or let's say with the letter A, we need to group them by the same letter. And for instance, in the initial case where we have the empty string, to do the grouping of the next state, let's say, we are going to classify only by the new character, because we know that the previous characters in this, or the prefix in the current state, is the same already. And if we are going to generate new states, then for these new states, in order to group them, we are only to group them by the new character that is being added. And for that reason, like to passing from this case to this case, we are doing the grouping by each possible letter. And for that reason, we need the length of the alphabet. Then after that we have this, we need to continue basically adding each of these new states independently to the kiwi, because our new state, let's rename this to something better, like new states, because they are more than one state, and this is a state. And also you could notice in the explanation that this case, this is an state, and this state will generate two different states. For that reason, we are creating here in the array, in the new states array, we're creating basically a matrix of 26 elements that basically each new character added could be one letter of the alphabet, one lowercase letter. For that reason, we are using 26. And each state by itself is a vector. Then after that we have the new states, we can start adding them to the QE. Okay, then this is let's say state if we need to validate that the new state is not empty, and let's say we're going to use a variable that is called stat length, that basically it's the quantity that we need to increase. The answer. Then for each let's say word index of the new state, we are going to increase the answer of the word index plus the length of the string of the state, sorry. And then we are going to perform the insertion of the new state to the kiwi, but we need to do some pre-processing regarding to that. and let's do it. We need to convert it to a vector of word state, and let's call it next. And we also need to basically reserve some memory for this. That will be the state length. Then we are going to traverse each word index of state, and we need to start adding to this vector. And for this we are going to add first the word index, and then we need to use the current state and any of the elements, because at the end in each state the position is the same. You could notice it, for instance, here all of the positions were 0, here all of the positions were 1, here all of the positions were 1 also, here all 2, and all 3. It doesn't matter from which element of the current state we get the position. The only thing that we need to do is increase, because yeah, in order to continue with the next characters of the string. Then we need to basically add the new state to the queue. Let's call it new state. Okay. Then we need to return the answer. Let's see if it compiles. Okay, some errors. Length alpha. Let's see. Then let's search about this issue using move in C++ style. Let's try with some of these libraries. I'm not sure which of them is required. Delete it. Yeah, I think that this is a problem with my compiler, because in the LeetCode compiler works without using std, because we are already declaring the use namespace. Okay, we have some typos. We use it. Okay, more issues. Okay, yeah. Now let's see what is the first case. String words ABC AB ABC and B. Okay, the first answer looks correct. Okay, the second answer also looks correct. Then let's send off our implementation. Let's see if this works. Okay, it's working. Then let's send it submitted. Okay, it's accepted. I hope that the explanation was clear. If not, please let me know in the comments. Thank you.